All right, so our relative extrema are the hills and valleys, if you will, in the function. They're not necessarily the highest points, although they could be. They're not necessarily the lowest points, although they could be. But they're the highest or lowest in a region. And you have this little diagram in your notes. We're also going to learn about increasing, decreasing, but we're going to save that for a moment. All right, so here we have an example of a function that has some relative max and mins. The tops of the mountains are the relative maximums because they're the highest point in their little neighborhood. So if your row here was a neighborhood, one of you would be a relative maximum. Whoever's the tallest would be a relative maximum. Might be Olivia. Right? So it's doesn't have to be it's not necessarily the largest overall or the highest overall, but the highest in a region. So notice this is a relative maximum here, this 2, 1. Right, that is a relative maximum. It's not the highest point because this point is higher. But they're both the highest points in their respective regions. And it basically looks like a mountain. So if you see a little mountain, that's a relative maximum. All right, so suppose you're in a room full of people, like your classroom. Find the tallest person there. May or may not be a guy. He is the relative max of the room. Specifically, he's the tallest relative to the people around him. So, I don't know. You the tallest? Maybe? So, what if you took the guy to the NBA convention? There would be a lot of people that would beat him, right? So it's not about being the highest value of the whole function. The highest value of this function, right, is going to be infinity because we see we have our arrow here. It's going to keep increasing, right? So the domain on this particular function is negative infinity to infinity, and so is the range, which means that our lowest value is headed to negative infinity. Our highest value overall is headed to infinity. But we're not looking for overall. We're just looking for a region. In this particular region, that's the relative max, right? And in this particular region, there's our relative max. And I think you have a similar diagram in your notes. I have it a little later on, I think too, and we're going to label it with relative maxes and relative mins on that same diagram. I think I already did that. So, although these guys keep going and beat out our relative maximum, we don't care. And these guys will beat out our relative minimum, but we don't care. We care about who's the largest or smallest in an area. So our function here has two relative maximums. It has a relative maximum at negative 3, 2, and a relative maximum at 2, 1. Let's go ahead and label that as a relative maximum. So in your notes, just label this as relative max and relative max. All right, those two are the largest points in the area. Notice we also have some valleys here, right? So this one's a valley, and here's a valley. Those are relative mins. So we have our relative mins are the smallest value in a region. So let's add our definitions here. So relative max is the largest, highest, I guess largest value in a region, and the relative min is the smallest value in a region. So officially for this graph, we have f has a relative max of 2 at x equals negative 3. has a relative max of 1 at x equals 2. It also has some relative mins. So let's add that. And relative mins of -3 at x equals -1 and -1 at x equals 4. So right here is our relative mins. So notice when we're talking max and mins, we're referring to the x and y values. But if I say what point is the relative maximum, you can give me the whole point. And usually that's what I'll ask for. I'll just ask for the whole point. Rather than the value and where it occurs, I'll just ask you what's the point that's the relative max, or what's the point that's the relative min. Any questions on relative max and relative min so far?
Do we write down the logbook?
Yeah, so write down the handwritten stuff on your diagram.
But we don't write F has relative max of 2x.
Oh, do you not have that in your notes? Oh, then don't worry about it. Don't worry about it. If you have the points, that's good enough. Yeah. All right, so the interesting thing for a parabola is that it only has one extreme value. It has a relative max or a relative min. If the parabola is facing concave up, meaning the starting value is positive, then we're going to have our relative min. It's the vertex of the parabola. Go ahead and label that as vertex. If the parabola is concave down, meaning that a here is negative, it's less than 0, then our vertex is going to be a relative maximum. Go ahead and label the maximum here as vertex, because it's called the vertex, but it's also the relative minimum or maximum of the function, depending on which way the graph is facing. I think that might be, I think we have some to label, right? Some relative extrema to label. And then I have an activity for you, labeling extrema. All right, so we're going to find the relative extrema. We may have to estimate a couple points, like in the first one. And it's okay. If it's not 100% clear, if your answer is reasonable, then it's fine. All right? So let's look at our first one here. All right, so I don't know. What do you think? Maybe at, looks like those points are going up by, each one of these is going up by 2. So looks like it's about, this point here looks to be about maybe -3. -310? And that's a relative max. All right, so we'll just put we'll put relative max. Because it's not the maximum, right? Because the function's going to keep on going. All right, it's going to keep on going to infinity. We also have a relative min right here. The points seem to be going up by 2. So that would be at 2, 0, we have a relative min. Go over to B. My cord will stretch. All right, so here's a relative extrema. Here's a relative extrema. Here's a relative extrema. One way you can tell you have a relative extrema is a little hint here. At the relative extrema, the graph turns around. It goes the other direction, right? So that's kind of a clue that you have a relative extrema, right? Because it was coming down, and then it turned around and started going up. And it turned around and started going down. And then it turned around and started going up. So, oh, this one's even funner. More funly. What do you think? Let's see. That's 20. That's 10. Maybe -6? -6. That's 30. Each one of these must be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not even 15. What are they going up by? Maybe 2? All right, so let's say that is -6, -2. I didn't choose the most clear graphs, did I? So let's do the hardest ones for the notes. It'll make the practice seem really easy. This one seems to be at 2, maybe 26. Oh, excuse me. -26?
-26?
Yeah, looks like about -26, because that's -30. All right, this one may be a little bit better. We have one here. It turns around. It has one here, and one here. So notice everywhere it turns around and goes the other direction, that would be a relative extrema. So it looks like that's -3, roughly. If that's -5, maybe that's 2. So let's call that -2, -3.
Ms. Bishagna,
Yeah.
do we need the third one up there or no?
Oh, I'm sorry. Yes, thank you. I missed one. So that one there is at, let's call it halfway. Let's call that -3, 1. We missed one of our extreme values. This one here, boy, this graph really leaves a lot to be desired. That looks like maybe a half, right? Because this is 5, so that's maybe a half. So let's call that -1, 1/2. Let me write that better. And then, is that in the right spot? Yeah. Looks like on the other side we have 1 at 1, -1/2. And then finally, that's probably about 2.5. So here we had to do a lot of estimating because the numbers are just not clear. It seemed like a good graph when I looked at it in the small. -2, -3. -3? Oh, you know what? I think that's a 5, not a 3. Make it -2, -5. Sorry. Yeah. I think it's a -5. I think. Because that one looks like a 5, so the other one should be a -5. All right, the last of these really difficult to read graphs. We have a turning point there, there, and there. Those turning points are your relative extrema. So if I say turning point, it's the same as extrema, all right? Because we turn around at the relative extremas. I'd say this one, I think each one of these lines is 1. No. Is that supposed to be -20? So each one is 10. So 10, 20, 30, maybe 40? Yeah. All right, that looks like -240. But then how can this one be 40 right there? Here. It is what we say it is. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70. So 160. So we'll call that 360. You get the idea, even if these were the worst graphs ever. And this one here, I guess it's at, if that's probably a half. -1/2, -10. So how much you can find, and I promise I won't give you ones like this.
Oh man, that's really difficult.
What an idiot.
And I didn't even notice how hard they are to look at. Somehow I don't have this page. Hopefully that's just in the wrong spot.
essentially.
Yeah. Oh, and let's label them as relative max and relative mins. So we did that on the first one, but not the rest of them. This one would be a relative min. This would be a relative max. Even if it's not very big, one's not very big, this would be a relative min. You just have to be the lowest point or the highest point in an area. This would be a relative min. This would be a relative max. This would be a relative min. And this would be a relative max. And then this would be a relative max, relative min, and relative max. Notice you can't have another max without having a min in between them. Let's hope that other page is, so I seem to be missing a page in your notes. Let's hope it's the next page. Yeah, I just have one more page left. Everyone got this in your notes? Good, okay. Let's see. Ah, there they are. They're just in the wrong order. So this is going to be really much, much easier. And they only have one extreme value. All right, this one's obvious. Even a little pixelated, it's obvious. So this one is our relative max. And that's at -3, 5. And then we have a relative min. And it looks to be about halfway between 4 and 5. So 4.5, excuse me, on the y, 4.5. On the x, it's 1. 1, 4.5. And there we go. So all you have to do from a graph is just look for the lowest or highest point in a region to find your relative extreme.